And liftoff. We have liftoff of Afternoon at the Museum. Hello, everyone. I am Janine Stanley. I am IRA's Director of Customer Communications. And today we're going to Mars on Afternoon at the Museum. I'd like to give you a little intro to Afternoon at the Museum, as we have a number of new folks with us today. And our Afternoon at the Museum show is a chance to spotlight what visual interpreting means when you go out and look at online content from a museum. We started our show as an effort to educate people regarding the Black Lives Matter movement and other social and civil rights issues. And we've kind of branched out from that, but that's kind of our heart and soul of this show. Well, today we are going to space, which is an equal opportunity place, and we have some very special guests today. Joining me is our host of the show, first of all, Stephanie Watts. Hi, Stephanie.
Hi, Janine. How are you today?
I am excellent. We have Ryan Bishop, our behind-the-scenes tech guy.
Hello, everyone. Happy to be here. I'm so excited.
Awesome. We have Agent Julia.
Hello.
The first agent in space. And we have our team from NASA. We have NASA Project Manager and also IRA Explorer, Dina Lambert. Hello, Dina.
Hi, everybody. Good afternoon.
And we have two of Dina's colleagues from NASA, Michelle Thaler and David Gruhl. Hello, Michelle and David.
Hey, nice to be here.
Hey, everybody. Thanks for having us.
Yeah, we are going to get into 90 minutes of excitement here, and we're going to start that excitement with a very famous video. So, Julia, if you want to screen share, we're going to watch 7 Minutes of Terror. I always love the title of this video because it just, it has you already on the edge of your seat.
All right, here we go.
Okay.
Looks like I'm shared.
Okay.
Go ahead and press play now.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Oops, sorry.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Perseverance, entry, descent, and landing.
Entry, descent, and landing is often referred to as the 7 minutes of terror because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from a spacecraft, and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given it.
The science team identified Jezreel Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezreel, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
Thrilling. It's so
Wow.
very cool.
It's incredible.
You might want to check your heart rate. It's kind of.
I don't believe it. I don't believe it.
It's already there.
Wow, amazing. Amazing.
That's fun. How many times you watch that video? It's like, oh. Okay. So, there we go. So before we go off to our conference here and our presentation, Julia, can you tell us a little bit about the Perseverance? What did it look like?
Okay, so I'm going to do just a brief description of the Perseverance rover itself. And I don't have a lot of technical knowledge about this, so I'm just going to give very basic visual information, and then our friends from NASA can fill us in about what all the different little pieces do. So I'm going to start from the bottom up. And so this rover has 6 wheels, 3 on either side, and the wheels have very visible treads on them. And they are each connected to the body of the rover by a spindly metal piece, almost like little spider legs or insect legs coming out of the side on either side of the body. And then the body itself is made of a large metal, it's almost a rectangular shape, but it's got lots and lots of, it looks like moving and important technical bits coming off of it. There's one piece that comes off of the front that looks a bit like a periscope. It's a skinny bit that comes out like a tube, and then there's some sort of instrument at the top of it. And then on the back of the body, there is a sloped portion. And at the front of the body, there's a long, what looks like a neck with some other instruments on the end of it, and it appears to be able to retract and raise and lift and fold and give all kinds of range of motion to that front part. So that's sort of a basic overview of what it looks like, and hopefully we'll learn a whole lot more now.
I have a question for the team, if I can jump in before you start. With the Perseverance, I think is the rover's name, did it fit inside of the actual aircraft that went up to Mars? Is that correct? Or
You're talking about its shape and how it kind of unfolded?
Kind of in how it got there. You know, I'm thinking back to the video. And again, maybe this is something that gets answered as you guys proceed. So I'm fine if you want to just go ahead and start talking. But I was just trying to imagine, how would this thing have gotten there?
Awesome. That is a great way to start out, actually, Stephanie. And what we're going to do is we're going to pretend we're going to this virtual conference, and we may stop our hosts from time to time, like Stephanie just did, to get some clarification from Julia, maybe about an image or a question that we may have. But I'm going to turn it over to Dina now and her colleagues to tell us exactly how Perseverance got to Mars and what it's going to be doing there.
Janine, do you want me to keep screen sharing, or should I stop for now?
Let's go ahead and stop. We can stop screen sharing for now.
Okay.
Cool. It might be helpful. Dave, what sounds like our point person for that particular question. And Michelle can answer some of the science instruments that are actually on the rover itself, and actually, her role as a scientist at Goddard.
Sure. So I'll jump in first. So I had, this is David. I had 2 key jobs on the Perseverance rover mission. My first job was I led the team whose responsibilities were to actually assemble the vehicle. Basically what we did is just like your kids who have Legos, we get delivered to us a lot of small parts and pieces, wheels and things like that. And my team then actually bolts the vehicle together. We test it to make sure that it works the way that it's supposed to work. We then simulate the launch environment and the environment of the spacecraft cruising to Mars, as well as the environment of the spacecraft sitting on Mars itself. So we make the spacecraft really cold. We take all the air out of the room and we make sure that everything works the way that it is supposed to work. And then once we confirm that the vehicle does what it's supposed to do, we take it down to the launch site in Florida. We put it on top of a rocket, and then we sit back and watch the launch vehicle team actually launch our spacecraft on its way to Mars. So that is a super exciting job to be able to participate in the assembly and test of the actual vehicle, which is now sitting on the surface of Mars. And it's great to be able to say that I've held hardware in my hands, which is now on the surface of Mars, hundreds of millions of miles away, and returning amazing data to us on what Mars actually sounds like and what the science and makeup of the rocks and things like that on Mars are. And then the second fun job, which I had in my limited amount of spare time, is I was responsible for putting some commercial cameras onto the spacecraft. And these cameras then captured video of the vehicle descending and landing on the Martian surface. And as an added bonus, the project decided to include a microphone inside that EDL camera system. And while that microphone unfortunately didn't record any sounds of the vehicle descending through the Martian atmosphere, it has recorded some pretty neat sounds on the surface itself. So on our second day on the surface, we actually turned the microphone on and it recorded wind noises from the surface of Mars. And then about a week and a half after that, we turned the microphone on during a drive across the Martian surface, and we could actually listen to the sounds of the wheels and the suspension system actually, for lack of a better word, pinging, popping, banging, scratching across the surface of Mars. So it was super exciting to be part of that too. So those are the 2 key jobs that I had. In terms of your description of the rover, Julia, that was really good. You did very well. You pointed out everything exactly right.
Thank you.
The periscope device that you were referring to, just like you said, at the top of that device, there are 6 different cameras which can look off into the distance, and it helps the vehicle not only image its surroundings, but they also can be used to help figure out how the vehicle drives across the surface. There's a neat science instrument up there which has a laser, which Michelle can talk to you more about, which can actually zap rocks. And by zapping those rocks and giving off some smoke, we can actually determine what the composition of those rocks are. Off the front of the vehicle, there is what we call a robotic arm, which reaches off of the front. At the end of that arm, there are additional science instruments, but that also is the key device which will actually collect samples on the surface of Mars. So there is a big drill. It's called a core. It can actually drill into the rocks of Mars. It can retrieve that sample off of that rock. It can pass it back into the rover itself for it to get put into a test tube-like device. It's a long cylinder. And then we'll actually put a cap on it and we'll drop it on the surface for another mission to come along and pick up in the future. And then on the back of the vehicle that you're pointing out, that is our radioactive power source. That is the device that actually generates our power. We don't have any solar arrays on the vehicle. Some of the last rovers did have solar panels on them, but both Curiosity and Perseverance are nuclear powered. And that device on the back actually produces a small amount of electricity. it can produce just about 100 watts of electricity. So it's not a lot, but we have a very large battery on board. And so when the rover sits there idle overnight, when it gets very cold out, that device is still producing electricity 24 hours and 40 minutes of a day, because that's how long a day is on Mars. And we just use all that energy to put into the battery. And then when we have to do things like driving or do science or communicating with the orbiters, we actually then extract power out of the battery to actually do those activities. And then once again, we start to charge the battery up again using that power that comes out of the radioactive power source on the back of the vehicle. So it is, the vehicle as a whole is very similar to the Curiosity rover that is already on the surface of Mars. We are a little bit larger because the sampling system that we put onto the Perseverance vehicle is a little bit bigger sized than what the Curiosity rover could handle. So we had to make the rover a little bit bigger. But basically, in regards to the question about how we get there from Earth to Mars, yes, the rover kind of tucks up. So for instance, the wheels, when they're on the surface, they stick out in order to keep the chassis of the vehicle up off of the surface and away from the rocks. But in order for us to fit into the protective device, which keeps us safe as we're cruising through space and then going through the Martian atmosphere, basically the periscope that's up at top of the vehicle, it lays flat. The arm that sticks off the front of the vehicle, it tucks up close, right to the chassis. And the wheels get tucked up close too. So that way we can put it inside the aeroshell, which is a lot smaller. And then when we get to the surface, we actually will deploy those devices so they can actually stick out and do their job. So yes, we do have to shrink the vehicle up in order for it to fit inside the protective cocoon of our spacecraft, as well as there are limitations on the size of the launch vehicle too. The launch vehicle says you can only be so large. In order for us to make sure we fit within those, we have to shrink the vehicle up and tuck it up nice and tight. Just like keep your arms and your legs close to your body, you pull them in tight, and then when you get to the surface, you can expand yourself out and then do the job that you're designed to actually do.
When it's fully expanded, David, how large is it with wheels out and periscopes up and everything is opened?
So so the top of the periscope is just about 7 feet off of the surface of Mars. The wheels side to side, that's about 6 feet or so if you were to go side of the vehicle to the side of the vehicle. And then front to back, that arm that reaches off the front can stick off very far. It can stick off over 8 feet from the front of the vehicle. So while the body of the vehicle is about 8 feet itself, the arm can stick out another 8 feet or so. So it can, the whole vehicle end to end is rather large once you actually get it into its fully deployed configuration on the surface of Mars.
Amazing. So when we say the word spacecraft, and this is just kind of my experience, when you say the word spacecraft as a blind person, it's like, okay, what does that look like? Is it a tube? Is it a box? And from what I understand, the deployment unit is more of a cone shape that has a kind of wok or skillet shaped bottom, and that deploys away. Am I correct in that assumption?
Yeah, that's a great description, actually. You got it really good. Yeah, it's exactly right. And actually, the only thing I would add is that on the top of that, we kind of view it almost like a top that can spin. But yes, there's a wok on the bottom, and then there's like an upside down, almost like an ice cream cone on top of that. But on the top of that ice cream cone, there's another circular piece which sticks out. And that circular piece is what we call the crew stage. And the crew stage has on board it some propellant tanks. It has some thrusters. It has some sensors. And the crew stage's job is to basically get the entire spacecraft from Earth to Mars. So it basically its sensors will detect where we are in the solar system. And based on that, the engineers will send commands to the vehicle saying, fire your thrusters in this direction or in that direction to make sure that we are on the perfect trajectory to intersect Mars right where we want to intersect it. And then when we get close to Mars, when we're just about 10 minutes away from the atmosphere, that cruise stage, that top circular piece basically gets jettisoned and it burns up in the atmosphere. And then what goes through the atmosphere as part of the spacecraft then is the walk on the bottom and then the upside down ice cream cone on top of it. And inside of that is the rover, which is what we want to get to the surface to be able to do its science and to drive around and to return all sorts of interesting information about the surface of Mars.
And so do we have sound and some other things that we can hear as we proceed today?
So we have recorded 3 sound. We recorded at least 3 sound files that I know are available. There's actually 4 I can think of. So we recorded a sound file with this microphone of the vehicle in the vacuum of space. And it was very interesting to us because sound needs to have a medium to propagate. So it needs to be, air, or it needs to be in the water. But in space, there is no medium, there is no air, there is no water. So what actually we discovered, which was an interesting find, was that the microphone that we used is hard mounted to the structure of the spacecraft. And it turns out the microphone in the vacuum of space picked up vibrations from a fluid pump that is on the spacecraft. So let me take one step back. The radioactive power source we use is very, very hot. And we use the heat from that radioactive power source to keep our electronics warm. And how we do that is we have a fluid loop, which is a pump, which basically, just like a car, it runs liquid through the very warm radioactive power source, and then it runs that fluid through the rover itself, and then that heat from the radioactive power source warms the electronics. So that pump that is actually moving the fluid around, it's got vibrations, and then the microphone picked up on those vibrations, and it came across as a sound indicative of the vehicle in the vacuum of space. And it's neat to sit there and listen to it and realize that this sound is recorded from the vacuum of space. So that was one great one. We then recorded wind from the surface of Mars.
I'm gonna stop. I'm gonna pause right there. I believe Janine or Julia, I think we have links to at least one of those sound bites. Can we pull those up?
Sure, let me see. Is it in the email?
Yes.
Okay.
I can send you a link too if it would help to where they all are located.
That would probably be easier if you can put it in the chat.
Yep, give me 1 second. I've got it now.
Cool.
That's just amazing to hear how sound got created in a place you're thinking you're not going to get any.
So actually, we'll put that link in the chat, but if you go to mars.nasa.gov, under the multimedia heading, there is a whole dedicated page to sound files. We will try to play a couple of those during this session now, but I counted at least maybe 9 sound files that you can actually hear, ranging from the laser deployment to the wheels moving, as mentioned earlier. So there's lots of good audio.
Lots of good audio.
That's the link I just gave you. Yep, that's exactly where I was going.
Would you like to play some of those now, or
absolutely, let's go for it.
All right, let me go ahead and share again, and I'll share sound, and then I will act as IRA agent for NASA people if you want to tell me which ones I should go ahead and.
So why don't you start at the bottom, Julia? So these are all ordered on this webpage. From the oldest one is at the bottom and the newest one is at the top. So the one I was just describing, which shows the vehicle in the vacuum of space, that's the bottom one on this webpage.
This one here, in flight?
Yep.
All right, let me click play.
Okay.
All right.
So in space, they may not be able to hear you scream, but they can hear your fuel pump there.
That was the
I
exact
was
quote
holding
they
my breath
used.
during that whole thing.
No, that's exactly right. It's just exciting to me to listen to
Well,
that
yeah.
and realize that's the vacuum of space.
Well, and the sound that was a kind of like I would call it a little bit of
A whirling.
the whirring sound, and then the other sound was that actually something moving, wind, or that's just a fuel pump, like Janine said.
Yeah, so that first audio was just the pumps by themselves.
Gotcha. Okay.
Now, if you listen closely, and it's probably best to, offline, you can actually put it on your headphones and you can really crank the volume up and listen to it even better. But you'll also notice there's some clicks that are heard throughout that sound file. And so it turns out that there are some fluid valves within that heat rejection system, that fluid loop. And you can actually, if you listen closely, you can make out the click of those valves actually opening and closing to regulate the fluid moving throughout the vehicle.
Okay.
So there's all sorts of interesting information that can be extracted by listening to an audio file, which we really didn't think we were going to record or hear very much because we were in the vacuum of deep space. We were about just under halfway from Earth to Mars when we actually made that recording. So we were deep in the middle of nowhere, if you will, when that recording was actually done.
And David, we had a question, and we'll take everybody's questions that were pre-submitted, but somebody did ask about the specifics of these microphones. What would they compare to in commercial audio equipment? Because we have a lot of audio nerds out there.
That is a great question. So I'm going to take another step back. I'm going to walk you through a walk down history lane for me. So the EDO camera system that went onto the rover was devised. The idea came up several years ago, and the concept was to use off-the-shelf hardware in order to catch some amazing videos, so that we didn't have the resources or the drive to actually go and develop a whole system from scratch. So the camera started off as off-the-shelf devices. And about a year later, NASA and project management came back and said, you know what? We think it would be amazing if we could include a microphone within that camera package. And so we were asked to take a look at it, and we did the same thing. I'll be honest, we did a Google search, and we started to look for robust, resilient microphones that we might be able to buy off of the shelf to put onto our rover to record audio of the vehicle descending and landing on the Martian surface. And we struck out for a while. We couldn't find a microphone that we thought would work for us. We found ones that we could use. They would plug into the existing system, but we didn't think that they would record good audio once we actually got to Mars itself. And then we stumbled onto a company which had just developed a new device that was targeted for reporters who were working in the field. A real high fidelity audio system is very large, and it requires a lot of power and electricity, and it's heavy, and we couldn't put something on our spacecraft, onto the rover itself. And in the reporter community, news people could not carry those things around with them when they went to do interviews with individuals. So this company over in Denmark had developed a device, and that device plugs into an iPhone or a Samsung phone, and it allows reporters to use their higher fidelity microphones with their existing iPhones. So you basically would pull this little device out of your pocket, you'd plug it into your phone. You would then take a higher fidelity lapel type microphone, clip it on the individual you were looking to interview, and then they would be able to record outstanding audio that they could use on YouTube type videos or things on the internet, stuff like that. And so this was the breakthrough that we were looking for. That device would allow us to use some of these higher fidelity, better sounding, better responsive microphones than we could use before that. And so we reached out to the company. Not surprisingly, they were super excited in the possibility of recording the first sounds from the surface of another planet. And so we basically teamed with them to use their equipment as the microphone for the EDL camera system. And it is the same hardware you could buy off of the internet. The only thing that we did to it is we did two changes. One is we took it and had to repackage it in a manner that we could actually bolt it onto the spacecraft. You know, we don't have pockets on the rover that we could slip this into and have it work with. Yeah. We had to physically bolt it onto the structure of the spacecraft. So we had to take this little device. It's how big do I think it is? It's small. It's shaped like a hockey puck, but it's a lot smaller. I mean, it's too small. So it's probably about, it's like that big there. So it's bigger than a $50 piece, but it's shaped like a hockey puck type of thing. And then the other thing we did is that the microphone that we used, it had a diaphragm, just like most microphones we use here on Earth do. And if that diaphragm got clogged with Martian dust, it would stop working. Mm-hmm. And so we worked with the vendor to put a special grate on the end of it that would work to keep the Martian dust away from the diaphragm, so that even in the dust storms of Mars, or when we're landing and dust is being kicked up by our retro rocket system, the dust would not penetrate the diaphragm and cause the microphone to stop working. Other than that, you could purchase this exact same microphone that we used on Mars today. And I'll tell you this too, as a fun little neat fact. I'm actually sitting here talking to you on the spare microphone that we didn't send to Mars. So we sent one to Mars and we made a second one. And the one that I'm talking to you on is the spare microphone that didn't go to Mars. So this is the exact same type of hardware that is on Mars right now.
I'm going to win Jeopardy trivia with that.
Yeah, that's awesome. And I have here a similar device to what David is talking about. Plugs into your iPhone, lets you plug in your microphones and equipment, similar kind of thing. But now I want the one you have, David.
Yeah, it's neat. I won't let it go. This is my little my baby now.
Yeah,
it worked for us, and I'm never going to let this one. This is the partner to what's on Mars. So it's my little memento for what we've been able to accomplish. And we returned audio from the surface of Mars, and we're able to share that with everybody for the first time. And that's pretty exciting to have been part of that.
So speaking of that audio, I mean, the machine sounds are wonderful, but let's hear that wind from another planet. I want to hear wind on Mars.
Yes, so hit the next one up.
Right here?
Yep.
Is it loud enough for everyone?
I would crank it up if you can.
Yeah,
it's a low rumble you hear about 10 seconds after the audio is started, but it's another one that's probably better to be done with your microphones outside of the Zoom.
Yeah,
but I would crank it up and try it.
Am I able to turn up the volume on Zoom?
So I would like to have Michelle kind of chime in here and describe some of the atmospheric conditions that would exist on Mars that could be a very hospitable environment for a rover, or not so much fun for a rover.
Oh, sure, absolutely. So, I mean, if you want, I have some slides about Mars and the landing too, but let me just answer that question. So, Mars has a very thin atmosphere compared to the Earth. And while it certainly does have enough atmosphere to have things like wind, and even clouds that we can see, even all the way with the Hubble Space Telescope. From here, we can see the clouds on Mars. At the surface of Mars, it's only about 1% the atmospheric pressure that we have here at sea level. So that's just
So
one
would-
1/100th of the atmosphere that we have.
So would that be similar to what you would experience, like if you were to climb a mountain and, you know, reach higher elevations on Earth, or is it totally different?
Much less. That's right. Much less. Yeah. So, you know, I know, you know, I used to work at the big Mauna Kea, the big volcano in Hawaii, and I would work up there at close to 14,000 feet. And I remember sort of calculating that the amount of oxygen up there was only about 60% of the oxygen that you would have at sea level. But that's actually the air pressure, while it's lower, is it's nothing like 1%. I mean, 1% is almost like you're in a vacuum chamber, like you're in a scientific vacuum that's going to suck the air out of something. You know, I mean, like if you did experiments in your high school, I remember we put a marshmallow in a vacuum chamber, and because all the air was getting sucked out, the marshmallow expanded, things like that. So no, it's very, very little atmosphere. And one of the things about having so little atmosphere is that means there are very extreme temperatures on Mars, again, compared to the Earth. So the average temperature on Mars, if you were to average sort of all the places on Mars, is pretty close to about 100 degrees below zero Fahrenheit. And so it's by and large a very cold place. Now there are some places that have that are very low in elevation, where there's actually a little bit more air, more Martian air. It's worth saying that Martian atmosphere is nearly all carbon dioxide. There's plenty of other little gases, little traces of things like, you know, methane and argon and a tiny little bit of oxygen and all of that. But by and large, it's pretty much all carbon dioxide. And
Michelle,
so it's yes.
I'm just going to jump in real quick and ask, are you able to screen share? I mean, we've got some folks out there who would probably enjoy seeing some of the things that you're describing, you know, if that works for you.
Absolutely. Let me share my screen now.
And if I understand correctly, Perseverance has a oxygen conversion system on the rover itself, because one of the missions is to produce oxygen that we can later at least manufacture ourselves once we move into the phase of manned missions, if I'm correct. I believe it's called MOXIE.
That's right. Absolutely. Yes, MOXIE. And the MOXIE lab at the Jet Propulsion Laboratory is one of the absolute coolest places to visit, because, you know, so often when I'm in you know, a laboratory here at NASA, it's fairly, you know, quiet, and everything is just sort of calm, and the instruments are not making very much noise. And the MOXIE lab reminds me more of like a Frankenstein's laboratory. There are lights flashing everywhere. There are sounds. It's a very exciting laboratory to be in. And the MOXIE instrument, just like you said, you're absolutely right. It's an experiment to see if we can isolate oxygen from the Martian atmosphere. There is a tiny little bit of oxygen, but not very much. And so the idea is to actually take things like, you know, the carbon dioxide, which is very common, and break it up into things like oxygen. And there's also an experiment, I believe it's called RIMFAX. I'm going to get, I have a list that I can make sure I have them all right, but that's actually a radar instrument. And it can actually, a radar is something that actually bounces waves, in this case, waves of sound. Well, I'm not sure. What wavelength is the radar? I don't actually remember, but that's sonar with sound. But anyways, it bounces you know, radiation down into the surface of Mars. It goes down about 30 feet, I think. Mm-hmm. And we're looking actually for small deposits of water beneath the soil of Mars. There's several good clues that there is water, liquid water, under the surface of Mars in small quantities. And so that's something that we're looking at as well. Now obviously having oxygen is wonderful for humans to breathe. I mean, that's what we need. Of course, we wouldn't want a pure oxygen environment. We've learned that lesson before. The air that you're breathing is about 70% nitrogen. So actually, we mainly breathe a gas that we don't even use. It just kind of goes in and out of us. And then oxygen is another 20% or so of the atmosphere. But you know, pure oxygen environments are very risky, because any little spark, you know, if it's pure oxygen, it'll start a pretty big fire. Combustion happens a lot more easily with pure oxygen. So anyway, let me describe the slide that I'm showing you. I'm showing you right now an illustration based on observations of Mars, of the entire planet Mars. And there is a small inset circle, I would say about halfway up between the equator and the pole of Mars. And then there is a box that shows you a close-up of that area, which is the landing site that we call Jezreel Crater. And I can show you some more images of Jezreel Crater as well. But this actually, as you heard from the video, that 7 Minutes of Terror video, this was a very exciting and significant place to land. And it also was very risky. Normally we would land on a much flatter place, so we wouldn't have to aim so carefully. But in this case, the spacecraft was able to guide itself in very, very well, autonomously, because remember that light, the signals we're sending back, radio signals, microwave signals, they all travel at the speed of light. And the day that we were landing on Mars was so far away that those signals took a little over 14 minutes to go one way. And so a conversation, it's like, help, something's wrong. 14 minutes for that signal to get all the way to the Earth. And then we'd have to solve the problem and say, oh, here's the solution. And probably more than half an hour would have passed. So the spacecraft had to be able to do this all independently. So in the inset image of this crater, the crater is about 30 miles across, and it's very circular. I'll actually show you a picture of it in the next slide. The next slide is actually a picture from one of our satellites around Mars. It's a high resolution image. You're seeing kind of a light brown sandy color. There are bits of it that are darker, and this is actually areas where the wind on Mars has blown dust deposits. You can sort of see a shape that reminds me of a very shallow giant plate, like a dinner plate, a round dinner plate, about 30 miles across. And on the edges of the dinner plate, there's a ridge of mountains. And that mountain's ridge, it's a crater. It was formed when a large object, an asteroid, hit Mars very, very long time ago, many billions of years ago. And unlike some craters that you see that are very deep and scooped out, this crater is very shallow. In fact, the rim almost kind of disappears in some regions. It's hard to tell where that rim of mountains is. And the shallow aspect of this crater is what we were really interested in, because this crater was filled in by a river. And on if you think about a clock face, round about between like 9 o'clock and 10 o'clock on the clock face, you'll see a channel, sort of a dark colored thin channel that actually winds around like a river on Earth does. And that is actually the dry riverbed of a river that was very wet and very much flowing about 3 billion years ago. We're not sure exactly when it dried up, but we're pretty sure that long ago it was very wet. And on the other side of the crater, I would say at about 2 o'clock on a clock face, you'll see another wavy dark channel leaving the crater. And in fact, this was actually an outflow channel. So a river came into this big 30-mile across crater, filled it up with water, and then the water actually even drained out of the crater. And I don't know if those of you out there, hopefully you're familiar with something called a river delta, that when a river comes into like a lake or an ocean, the Mississippi River drains into the Gulf of Mexico. And when that river goes to a deeper body of water, it drops what we call sediment, rock, dust, material, organics in the case of Earth that have all been in the river. And now it drops down to this deeper area. And over time, this builds up a structure we call a river delta. And most often they're shaped kind of like fans with the, if you think about like a Japanese fan, a fan that you fold out, that forms sort of a triangular shape. The very narrow bottom of that fan is what would be connected to the river. And then that the broader shape that you fold out, that would then lead into the lake itself as all of this sediment drops out. And the reason we chose this location is we think that billions of years ago, we're certain that there was a lot of liquid water, probably global oceans on Mars. Exactly how extensive those oceans are, we don't know yet, but that's one thing we're exploring. But this crater would have been a lake of liquid water. Mars would have had an atmosphere thick enough to actually have liquid water, because with only 1% of the atmosphere that you have on Earth, any liquid would actually boil away. We're not really aware of this, but you need air pressure to keep liquid as a liquid. If you were to put a cup of water out into space, it would immediately boil away and become crystallized and actually just become a vapor and then ice if you're in space. But so we actually think that in this river delta, we have billions of years of Martian history and possibly evidence of any life that would have been in that water is buried in that sediment, in those layers of one layer of mud after another that was built up over billions of years. And so this is a very exciting place for us to land. We wanted to land where this river met this huge lake and dropped all of its stuff out, including possibly early signs of life. The earliest signs of life we have on Earth come from about 3.8 billion years ago. Those are the first chemical signals that something was changing the environment around it that we think was life. And that's what we're looking for here. I mean, we would obviously love to find, a seashell or something, or a fossil, but what we're actually expecting to find is just areas in the soil with very different chemistry, one area being different in another. And
yeah, that actually speaks to when we say life, a lot of people may believe, okay, are we looking for dinosaurs? Are we looking for, Martians that we see on, we grew up knowing on television, but actually it's at the microbial level of existence.
That's right. That's right. Okay. Yes. There's another organization called SETI, the Search for Extraterrestrial Intelligence, and they look for radio signals from actual civilizations. These are very, very excellent, serious scientists. These aren't people that, believe like, UFOs abduct people and they wear tinfoil hats. These are really, really good scientists. And, they actually have teased me several times. It's like NASA is looking for pond scum, and actually things even smaller than pond scum, things like germs, maybe even a virus. But I would be really excited to find Martian pond scum. I mean, the fossil of it, the evidence that had been once there. And by the way, we are not certain that Mars has no life today. This is very controversial. This is one of the things we're trying to find out. There's no evidence of very large or complex life anywhere on Mars, but there are some indirect things that could be signs of life. We don't know yet. One of them is the emission of natural gas, methane. An organic gas. Organic means a molecule that's based around a carbon atom structure, and that's what we're made of. And so chemistry similar to us, we call organic chemistry, or we're based on that. So finding organic molecules doesn't mean you found life. It means you found a molecule similar to the chemistry that we have. But some people believe that there may still be microbes, mostly under the surface of Mars. And in fact, something you might not know about our own planet is that if you actually measured the mass of all of the life on Earth, I mean, everything, take the ocean with blue whales in it, and all of the giant, elephants on land and everything that exists on land, the greater mass of life on Earth is bacteria under the soil, under the surface of our planet. And some of that may have survived with pockets of little liquid water, even after Mars basically died. It basically lost its ability to support water on the surface.
So Michelle, you mentioned
yes.
So you mentioned layers, and with the rover itself, because I have a 2-year-old son that's probably digging up dirt probably right now.
Excellent.
I know that the rover has a much more precise way of getting to those layers. In my mind, I'm thinking of a cake.
Yes.
But does the rover itself take samples at various depths that we're looking for? Or is it grinding? Because that was the method that Curiosity used.
Right.
How are we evolving in the techniques that we use from the previous rovers, Curiosity and Spirit, to what we have now?
Absolutely. And it is very different from Curiosity. Curiosity had the ability to it's hard to say drill down, because it didn't drill down very far. It was really only on the order of something like 10 centimeters, but it could basically basically scrape off the surface of a rock. And then you get a nice clean sample without a lot of dust on it. And then, I mean, it was actually a different sort of laser, but both of these rovers have lasers that then fire and basically make little puffs of smoke, basically vaporize some of the rock. And then those molecules coming off that can be analyzed as well. So you're right. I mean, so Curiosity, the other large rover, had the ability to take Martian. People don't like to use the word soil, because soil implies that something was once living, like all of the soil on Earth. So they call it regolith, but basically that means the same as soil, lots of tiny little bits on the surface. And it actually put it right into an instrument called SAM, the Sample Analysis at Mars Instrument, which was able to do experiments almost like molecule by molecule, figuring out what stuff was in there. In the case of this rover, we're mainly using spectroscopy. We're using sort of what wavelengths of light something emits. When we turn it into a puff of smoke, or even if we look at rocks from a distance, we're using the way that it responds to light to actually tell us what the minerals are inside there. One of the things I hope to do in the future, or I hope NASA does in the future, is send a rover that can actually drill down maybe 10, 20 feet and take samples from all the way up and down that. I would love that. We actually have another Mars mission now called InSight, which does have a probe that can drill down, more than 10 feet into the ground. But that's actually just to take temperatures. It's actually not to analyze the chemistry. So unfortunately, we don't have that yet. But we have wonderful instruments. There's the Sherlock Instrument, for example. That was sort of on this long neck that you said that can extend 8 feet out from the rover. And the Sherlock Instrument can actually sample, sort of some of these things. And also it's actually making little capsules that we hope to actually return samples later. That's a big part of this mission, is that as it goes around for the next couple of years, I hope, it's going to be dropping little small canisters, maybe about the size of a tube of lipstick, very small. And we're going to be partnering with the Europeans on a different rover to bring those samples back in about 10 years. I'm really looking forward to that. Yeah.
Michelle, I'm going to jump in and ask
Please.
real quick. Julia, is there anything visually that, and Michelle, thank you for such a just comprehensive description using the clock face. That was very helpful to me. But I'm just wondering, Julia, is there anything else that you're seeing in any of the slides that you might want to?
I do have a few more if you'd like. I have this picture, which I should have shown you, which is an illustration, an artist's conception of what this lake would have looked like. Yeah, so it would have been filled almost to the brim with water. So in this case, again, you see this very, very shallow plate-like lake, very circular. And it's seen at an angle here, and you can actually see the river draining in and the other river draining out. So, this was a place where we had a chance to collect lots of gunk, lots of everything that fell out of that river and fell out of that lake over perhaps billions of years. Let me put it to you this way. There's no lake bed on Earth that old. The Earth changes so much because, we have erosion and wind and water and rain, but we also have plate tectonics. The continents move around and there are volcanoes that spread new lava over everything. And so there's nowhere on the surface of the Earth where we have the bottom of a lake from this far back in the history of the solar system. And this was the time that we believe life was starting. Definitely on Earth and very possibly on Mars. So this will be our first, as a species anywhere, our first chance to sample what a lake was like 3 billion years ago.
That's amazing.
Yeah, and let's see, what else do I have here? Oh yeah, so I just have a little inset of where the Mars Perseverance rover landed, and you can see that there is this river again draining sort of through, actually kind of making a little bit of a gap in this rim along this big plate, and there is this sort of fan-like shape as it has dropped all of the stuff all the stuff has sunk to the bottom of the lake. And the layers actually are there for us to sample. We don't need to drill anywhere. As we move through this river delta, and as we move up and sort of out of the crater, which is the plan, we will be sampling different heights of that delta. And each layer will be from a different part of Mars's path. So in some ways, Mars sort of did the drilling for us here. And that's a wonderful place to land. I'm so excited about what's going to happen in the coming years. And actually, I want to play this for you, and then I can stop with my my things. This is actually a video, and you'll hear sound too, of the very last phases of landing on Mars. And the footage, for those of you that can see this, is real. Dave mentioned that there were 2 cameras that were placed, two commercial cameras, one on the rover itself looking back up at the spacecraft as it's lowered down, and one on the spacecraft looking down at the rover. And you're going to hear the engineers very excitingly say, we're about to start that sky crane, right? So the sky crane is going to lower it down on wires to give it a nice gentle landing. And one thing I will say that can sometimes be a little bit misleading about this video is that we didn't have these images at the same time these things were happening. The images actually were downloaded after the landing. We had shorter, easier to just sort of ring out little signals from the rover as to what was happening in the spacecraft. And then later on, we were able to actually beam back this wonderful high resolution television signal, which I've never really seen before on a planet. So let me play that, and then I can actually even stop and start it if we want to talk about anything. So it's very short. So here we go.
Meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
One of the things that you're seeing in this now is you're seeing the sort of rusty red surface of Mars that's actually below the rover, and there's wind blowing all around it from the actual rockets, the small rockets that are keeping the spacecraft aloft and now gently lowering down the rocket. And there are two windows that are inset to the left hand of that. And right now they don't look like much. They just look like looking at some cabling and looking at some metal. But what you're going to see is the actual image, one from the rover looking up and one from the spacecraft looking down, of this wonderful chemical laboratory being lowered onto the surface of Mars. So let me play that bit.
Skycrane maneuver has started. About 20 meters off the surface.
And here you can see it being actually supported, hanging down from the spacecraft.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
And then now you see everybody cheering and jumping up and down. And of course, everybody is wearing masks. You know, I've been to several events this year where people wanted to hug each other and they wanted to high five each other. They would touch each other because everyone was so excited. But of course, we can't do that right now because of the pandemic. And I even, in October, I hosted the arrival of, well, not the arrival, I hosted the sample taking of an asteroid 200 million miles away. And same thing, we were all masked up. We couldn't hug each other. That was a hard part of this year. So that's
so Michelle and Dave, what does the, when I hear the word crane, or the sky crane maneuver, are we thinking of like thin cabling that's just one cable? Is it multiple cables that extend out? And then the apparatus itself, is it similar to a helicopter? I'm kind of curious as to what that would look like itself.
Hey, Dave, would you like to describe that?
Sure. So there are four things that hold the two vehicles together. There are three mechanical devices. It's not wire. It's actually made up of a material which is very similar to the material that goes into a police person's bulletproof vest. And so we start off with the rover and the jetpack physically connected together with bolts. We then fire pyrotechnic devices which cut those bolts. The bolts basically will fall apart. And then what happens is then the rover starts to slowly descend below the jetpack. And so the four things holding it are these three Vectran bridles, which are like wires. So there's three things that are holding the two vehicles together. That's basically allows the descent stage. It's firing its thrusters and is pushing up, and it's holding the rover off of the surface and slowly going down. And then there's one other connection, which is a bunch of electrical wires. And that's the bundle, which actually there's some sensors up on the jetpack, and there's also the camera on the jetpack. We pass signals from one vehicle to the other, from the descent stage to the rover, through that electrical cable until the point that the rover touches down on the ground. And then once the rover actually makes contact with the ground, a command comes from the computer of the rover, which says, cut those bridles and cut that electrical wire. And it's just like it's a guillotine, similar to a pair of scissors. It fires another pyrotechnic device. A metal piece cuts through those bridles that are holding the two vehicles together and the electrical wire. And then once that happens, the descent stage, then the jetpack flies off into the distance until it runs out of fuel. And then once it runs out of fuel, it crashes onto the surface. having done its job and successfully delivering the rover onto the surface.
Wow. Wow.
Thank you, Dana, for asking that question. I was curious too.
Now, one thing, piece of hardware that Perseverance is carrying is an actual helicopter. But the location of this helicopter is kind of interesting. If I'm correct, it's below the rover itself. Is that correct?
That is correct. Yep. So it's right now, the rover, the helicopter, once again, it also had to be tucked up, pulled all its legs in, pull its fan blades together. So we made it as small of a package as we could make it. And then we attached it to the bottom of the rover. And then we put a protective cover over the top of it. And the protective cover was meant to keep the dust that we generate as we're descending onto the surface of Mars. As you heard, those rockets are firing and they're kicking up dust. We wanted to make sure that that dust and those small rocks that are getting kicked up couldn't damage the helicopter. The blades of the helicopter are very fragile. And if one of them got hit with a rock, basically the blade could break and then the vehicle might not be able to fly. And so once we got down to the surface and we made sure the vehicle was okay, we started to look for a good location where we could drop that protective cover onto the surface. And just about a week ago, we dropped the protective cover and revealed the helicopter for the first time. It still is tucked up in a little small cocoon, if you will. I mean, it's not protected, but it's pulled up into itself. And just about a week from now, the plan is to actually rotate that and drop it on the surface. So drop is, it's a relative term. Its drop is going to be a couple of inches is where it falls down to the surface. So it's not getting dropped from tens of feet above the ground, which could damage it. So we rotate it underneath the rover so its legs point downward. And when it's in that configuration, it's a couple of inches off the ground. We then send a command to actually cut the helicopter free, and it drops from the bottom of the rover, and its four legs will then make contact with the ground. And then a very time critical event is we need to then drive the rover forward so that it's not covering the helicopter anymore. So once the helicopter is dropped from underneath the rover, it's on its own. It's responsible for keeping itself warm. And it does that by having electrical heaters. And in order for those electrical heaters to work, we need to make sure that the helicopter can see the sun. And that way its solar panels will generate electricity. Well, if it's underneath the bottom of the rover, its solar panels are shielded from the sun. So we need to drop it, and then our clock starts. We need to then drive the rover forward so that the helicopter's solar panels can see the sun, so it can then generate enough electricity to keep its battery charged and then keep its heaters going to keep it warm through those cold temperatures you heard earlier that happen at nighttime on Mars.
And so Dave, the helicopter then, once it's dropped and deployed and the rover is moved along, will NASA maneuver the helicopter for picture taking purposes, or what is the role the helicopter will play?
Yep. So the helicopter itself, let me describe the helicopter a little bit, what it looks like. It's very small. It's probably from the bottom of the legs to the top of the rotors, it's probably about 2 feet. There has 4 legs that stick off of each of the corners. The very center of the helicopter, it's a cube in shape. It's probably, let's say it's about 6 inches by 6 inches by 6 inches. And in that cube, it holds the electronics and the computer that are used to actually control the vehicle. It holds the power subsystem, which is the battery and the device which turns the solar panel input into electricity. And it also contains the motors, which actually spin the rotors and adjusts the rotors to control the flight of the helicopter itself. And the helicopter has It has 4 blades, but it's 2 rotors. So basically sticking up off the center of that cube, there are 2 rotor blades which spin in opposite directions. And that's how it basically keeps itself stable, by spinning in opposite directions. And then it's how it gets the lift that it needs by spinning those rotors. It can then lift itself up off the ground as it goes faster and faster. So the plan is, absolutely, once we drop the helicopter onto the surface, at the end of that robotic arm, which sticks off of the front of the rover, there is a camera on the end of it. And so the arm is going to kind of look down underneath the vehicle, and we'll take a picture. We might even get some very slow rate pictures, almost like a video, but you're only going to get an image or 2 a second of the helicopter being dropped, landing on the surface. Then we'll move the arm up out of the way. We'll then drive the rover, I think it's forward. They had discussion about going forward or backwards, but they'll go one direction or the other. We can go in both directions on the rover. And then they'll stop a short distance away and take images of the helicopter on the surface of Mars. Then after they get those pictures, over the next couple of days, the rover will continue to drive away. And once we get a good distance away, a safe distance away, they're going to then spin the rotors of the helicopter up, not to the point it can fly, but just to show that everything works as expected. Then the rover is going to drive either even further away. And then the next opportunity to spin the rotors on the helicopter will be to actually take flight. And they'll actually lift up about 10 feet off the surface, hover there for tens of seconds, and then they will then descend back onto the surface, and having done a successful flight on another planet. And they plan to do 4 or 5 flights over 30 days of Mars. And each subsequent flight will get a little bit more aggressive. So the first one's up and down. The next one will be up a little bit to the side, back to the middle, and down again. And then with each subsequent flight, they'll get more and more aggressive, going up faster, going to the side faster and longer, and then coming back to the place that it started. Eventually, if the helicopter is successful after its 4 flights in its 30 days, to answer another question we usually get, yes, the rover will drive away from the helicopter and leave it behind. And that's because the helicopter is a nice to have technology demonstration on 2020. And the 2020 mission has some very important scientific objectives that it has to get onto. We need to start collecting the samples. We need to start exploring that river delta you heard about. And in order to do that, we then need to move on from the helicopter portion of this mission and focus on the science and sample gathering portion of the mission.
Okay. Very good.
So, so for Michelle and Dave, I believe, Michelle, you had mentioned that the rover will traverse the riverbed. I'm not sure as to how, like, what the shape of the route will be, but I know that there is a primary mission and also extended mission. And I believe the extended mission is to go into the rim. Is that correct?
That's right. So, I mean, at NASA, we basically have mission success defined by all of our major scientific goals that we hope to accomplish relatively quickly. But of course, we hope things will last longer than that. In the case of the Curiosity rover, we're getting pretty close now to coming up on the 10th anniversary of it landing on Mars. And another one of our the Opportunity rover, I believe, lasted almost 13. It lasted a little more than 13 years. So, I mean, hopefully this will be there for a while. So, yeah, the river delta is although it is certainly an incline, it's a gentle enough slope that the rover should be able to move up it, slowly and carefully, and actually, get out of the crater and sort of go into the riverbed area. I will try to send you a link. There is actually some published information about what route they think they're going to take right now. And then this, of course, may change. They may have different ideas. One of the things that I thought was rather lovely is that we've started to name different locations as we start to begin studying where the rover is. And the first one was named by the Navajo Nation. They named it, and I'm not sure exactly that I'm pronouncing it right in their language, but they named it Maz, which actually, even though I think that's a coincidence. It does sound very much like Mars, and that was really a nice thing. One of the things
Actually,
I wanted to mention.
Michelle, it is Mars. That is the Navajo word for Mars.
I wasn't clear. Yes, I knew
okay.
that. Yeah, that's right. Yeah, that was the Navajo word for Mars, and I don't know whether it's a coincidence that the two sound so similar or not. But the Navajo language is just one of these absolute human treasures. It's very, very rich and layered, and I'm looking forward to more of that. The other thing I wanted to, of course, remind you is remember the helicopter is working at only 1% the air pressure that we have on Earth. That's amazing. When they first proposed this, I thought, can you really do that? But in fact, I'm looking forward to seeing that. And of course, they did test it in giant vacuum chambers, specifically, I believe, in Houston at the Johnson Space Center, and so it should be able to fly, under those conditions. Coming up, actually, in the next decade of exploration, we have a mission called Dragonfly, where we are going to be, in this case, guiding an octocopter, one of these things that we think of today as sort of like a drone, a large vehicle that actually has 8 different spinning blades on the 4 different corners of a large box. But that large box is about the size of a car. So we're sending that to a moon of Saturn. And in this case, the moon of Saturn we're sending it to has a thicker atmosphere, more atmospheric pressure than Earth. And so it should be able to fly quite easily. So I'm looking forward to, this is our first powered flight. This is the Wright brothers moment. This is the first powered flight on another planet. And then in a couple of years from now, launching Dragonfly, which is going to be a big monster thing. I mean, wow, I'm looking for that a lot.
It'd be a good time to jump in and take a look at that helicopter and get a description if you guys want to do that.
Yeah, and I wanted to check in with Janine. I mean, this is a great conversation. We could go on for days. But I want to make sure.
Yeah, I know there's questions.
Yeah, I want to make sure we're covering the questions that may be coming in the chat or.
Absolutely. And let's take a look at the, at the helicopter. I'm so excited because we're going back to Titan, aren't we? Oh, I'm so excited. Anyway.
Titan is the name of the moon of Saturn. Absolutely.
Yep,
I'm looking forward to it.
That's what I thought, that vehicle on Titan. But yeah, and then we can, once Julia describes this, we can get to some of the questions that we have here because you guys have covered a lot of them, but we have a couple really interesting ones for you here.
All right, so I have a photograph here of the surface of Mars, and it is a rusty color. You can see some small rocks standing up from the surface that's just flat, and around in the background, you can see some raised rock outcroppings as well. And in the middle distance on the surface, you can see the rover itself standing on the ground. And then flying above and away from the rover is the little helicopter Ingenuity. And as Dave had described, it's a box in the center. It looks like a shiny silver metal box. And it has 4 long legs with little feet coming out of the top 4 corners of that cubical box. And then there's a little joining section, and it looks like some rotors, and then another joining section and some more rotors, and a little flat part on the top. And in this photograph, the rotors are spinning so fast that it just looks like a blur. You can't really see any individual
actually
pieces.
I think the rotors have to spin faster. Is it 2600 RPMs, I believe? Is that the correct measurement?
Right. Good job. Yep, that's
awesome. Awesome. And that is much faster than what you would find here on Earth, I believe,
in the typical helicopter that we have. And when you guys were mentioning helicopters, my mind said, how would they have put a helicopter under it didn't occur to me that it would be so small.
Yeah, one of the major components that you have to look at when you're looking at flight is the mass of what you're flying, and then also the size, because fuel costs money. You have our own gravitational factors here on Earth that you would need to gain lift, and anything that we build, we have to factor in mass, weight, and size, I believe.
And Dina, I just want to segue for a quick second before we go to some more questions. Would you mind sharing your role there at NASA?
So So I'm a project manager within our Mission Operations Directorate at Goddard Space Flight Center. Goddard is one of 10 field centers within NASA. We have over 80,000 employees. I wear a lot of different hats, but one of them is mainly bean counting or money counting. So when we look at our mission objectives, we kind of look at, okay, how much money do we have and how much can we dedicate towards those science objectives, the procurements that we're going to. I'm sure the nice microphone that Dave had mentioned, some contract person was involved in making sure that we could purchase that item from Denmark. But my role is more on the business administrative side of it, though I am a science enthusiast.
I marvel. I mean, I thought, did I miss it? Is she one of the scientists too?
Well,
all of
that's
you
the
guys
great
are amazing.
thing about NASA is that it to work at an agency that is looking at our own home here on Earth, but also beyond. It's easy to get engaged with our mission, whether you are working as a scientist or an engineer or safety, or even in our business administration area like I am.
Amazing. All of you guys are amazing. I just wanted to let you know that I am fascinated with this presentation today. And Janine,
we could probably
time
stay
for
here
some
for
questions,
hours.
or?
Yeah, we have a question here about satellites. And the questioner asks, are there satellites on Mars or surrounding Mars for communication and data transfer? And if so, what is their transmission? What are the parameters for their transmission?
That's a good question.
Yeah, I can start with that one. So there are assets that we have in orbit around Mars, and they greatly enhance our landed rover missions. What it allows us to do is that we can carry much smaller communication packages on our rover, because instead of having to downlink all of our data from the surface of Mars all the way back to Earth, we just need to transmit that data up to an orbiter that's in orbit around Mars. And then that orbiter transmits the data back to Earth. So good question is, well, what's the difference? So what the orbiters have is they have very large antennas. They have antennas that are, for instance, 2+ meters across. So say 7 feet or so across. And what that allows them to do is when they point that antenna at Earth, they get a very large signal gain out of it, which means they can get much higher data rates between Mars and Earth than we can get from the surface. We only have small little antennas on our rovers, once again, because we couldn't put something that large and get it to the surface. It takes up a lot of volume, they're heavier, and you need to be able to point them. So we sit on the ground, and we're buffering all of this amazing imagery data, sound data, information on the health of the spacecraft. It's getting all buffered up. And then an orbiter passes overhead, and using a UHF link, ultra high frequency link, we transmit that data from the surface to the orbiter. And in some of these communication sessions, we're getting over a gigabit of information, which is a lot from the surface of another planet. And then the orbiter receives that data. It then points its high gain antenna back to Earth, and then it blasts all the information back to Earth coming from the surface of Mars. So it relays all that information from the surface and allows us to get a lot more images, a lot more data from the surface than if we had to communicate directly from the surface itself.
Wow. And a related question here, how long does that take? To get all that image, for one pass?
So a pass is usually, it's relatively short. It's actually, when an orbiter comes overhead, it's something on the order of 10 minutes or so. And so we send data up to the orbiter at a high rate, but the signal doesn't go very far. So it can get to an orbiter going around Mars, but there's no way it could be detected all the way here on Earth. And so we send up a lot of data in 10 minutes, and then that orbiter turns around and sends it down to the ground at a much higher rate over a much further distance. Instead of going, many tens of kilometers, it then turns around and sends it millions of kilometers back to the Earth using a high gain antenna and a much more powerful downlink system.
And actually, I have a fun thing to add here. If I can share my screen, I can show you some of the images that were taken during the landing and give you a sense of how accurate we are. So the first image I'm going to show is actually an image of the Curiosity rover, the older rover. So let me share my screen here, and then I'll start this presentation. There we go. Can you see an image in front of you? It's an image of, again, looking down at Mars, which is kind of rusty brown. And we're actually at the edge of the crater that Curiosity is in, Jezreel Crater, another really interesting ancient lake. And you see sort of there's a kind of a dark shadow of cliffs around the edge of the crater. But then down at the very bottom of where the cliffs are, there's a small little, just kind of little light smudge, and there's a box around it. And you can expand the image. There's an inset image. That's actually the Curiosity rover seen all the way from our satellites around Mars. So the Curiosity rover is the size of a small car. And so, we actually have imaging capabilities on Mars that are so good, we can see very, very small things on the surface. And the next one is just so much fun. This is actually the landing of the Mars Perseverance rover. And what you're seeing here, again, from the Mars Reconnaissance Orbiter, MCO, is you're actually seeing an image of the parachute opening. So, I mean, think about that, right? Here we go streaming into Mars at between 12 and 13,000 miles an hour. We're slowing down little by little until finally we're going slow enough to start this parachute opening up. And we were able to see that parachute opening from satellites around Mars. So you're looking at, you can see the edge here. I mean, this is a perspective shot because now we're closer. We're actually close to Mars. You can see a little bit of the edge of this flat plate crater with the, you can see the river coming into it. Sort of the river delta is at about 9 o'clock on the page. And then you can actually see a little white smudge with an inset image. And the inset image has the round sort of half bowl shape of that big parachute. And I just have to say one thing about that parachute. I think that parachute is so cool because as the parachute unfurled, we realized there was an interesting pattern on it.
Yes, that's what I wanted you to bring up.
So what's the story of the pattern? Do you know?
Oh, it is a code.
Yes.
Dave, I think it is a code from JPL, I believe.
I'm actually showing a diagram of it now. In this case, it's an illustration. It's not a photograph. It's an illustration. So you can see very clearly that in binary code, there are letters and numbers. And Dave, would you like to explain what it says?
I'm going to take a guess and say hi, Earth.
So the previous director of JPL has basically, one of the JPL mottos is we dare mighty things. And so it's not only for JPL, it's also for everybody in the United States. It's also for everybody in the world. These missions aren't necessarily easy to do. They are super challenging to do. And so the return can be amazing. And so if you're willing to take risks and you're willing to do things that are mighty, the return off can be significant. And as we're seeing from our Mars rovers and the possibility of doing sample returns and all sorts of amazing science on the surface of Mars, it just fits very naturally that, what's become a JPL motto is what is actually embedded in code into the parachute that's that got Perseverance to the surface of Mars.
Very cool.
In the illustration, you can actually see letter by letter. There's an inner ring that says DARE, D-A-R-E, and then mighty things. And on the very outer ring, I believe there are the coordinates and longitude and latitude of the Jet Propulsion Laboratory. Isn't that right?
Oh,
that's correct. That gets you.
Wow.
If you plugged it into your Google Earth, it'll basically get you right to the visitor center of the Jet Propulsion Laboratory in Pasadena, California.
So
I was going to
Janine,
ask that in Pasadena.
yeah,
it's so much fun.
I believe Janine has a very interesting resource for our really enthusiast, space
do.
enthusiast, the 3D printing, I believe.
do. So the folks at C3D.com, and that's SEE, the number 3 and the letter D.com, they produce 3D models, and they have access to NASA's library of 3D models. And they actually will make you a model of things like the International Space Station, the Curiosity rover, the Spirit rover, the Opportunity rover, a number of astronomical kinds of things like images of constellations and things like that. And they send those to you with a written description of the model so that you will know all of the parts of the model. And I know that even on the rovers, the wheels move. They have them printed so that they have movable parts. But you can see all these things. And I don't know if they have Perseverance and Ingenuity yet, but please check these folks out because they are incredible. It's a volunteer effort that they make these. They do not charge for them. And they do take donations though. And so please.
I think I want to see if I can get the parachute. That it sounds really beautiful with the motto. That would be awesome.
Yes.
I love that. I thought it was going to be a QR code and you would read the QR code.
The motto actually comes from President Roosevelt during World War II. That was the idea.
Wow.
He was talking. I guess I have it here. That the quote is from President Roosevelt. Far better is it to dare mighty things, to win glorious triumphs, even though checkered by failure, than to take rank with those poor spirits who neither enjoy much nor suffer much, because they live in the great twilight that knows neither victory nor defeat.
Oh.
So, the idea is dare mighty things, dare to fail, and hopefully there will be some victories in there as well.
Awesome. Well, we are daring mighty things here on Afternoon at the Museum. And in our last few minutes, I want to find out from Dave and Michelle and Dina, how can we, with our help of our wonderful IRA agents like Julia, explore more of this content? Where can we go on the web to see more of these images and maybe to hear more of the sounds of Mars? Because we're going to go out with the sounds of the rover moving around.
Well, certainly, you can find such great web content on mars.nasa.gov. I mean, just that simple, and that's where you can find the audio files that we talked about, and there are more of those. Not necessarily specifically with Mars, but I've worked several times with a woman named Noreen Grice, who does science books, tactile science books. So we've done science books about the sun. We've done about the Hubble Space Telescope, and I'm sure she also has some. I think she has one about the moon. I'm not sure about Mars, but those are really wonderful.
Not yet.
Not yet. Yeah. Okay. That's right. So soon.
We got to put a plug in with her to get that one going.
Well, the sun one is one of my coffee table books, actually.
Right.
Oh,
Very
wow.
cool.
So mars.nasa.gov is kind of your one-stop shop for this particular content. If you are interested in, looking at that with an IRA agent. And if you would like to have NASA invest in IRA as an access partner, we are working on that, folks. So let us know if you are enjoying this content. And apologies for the commercial there, but we so much appreciate
Very good. Yes.
all coming, and we could be here for hours. I'm telling you, we haven't even gotten into my favorite sound from Mars, the laser measuring the rocks. And that's a whole program about Martian geology that I would love, Michelle, for you to come back, and Dave as well, to come back and talk to us about, because I find it absolutely fascinating.
Absolutely. And we have a wonderful audio podcast at NASA called Curious Universe. Curious Universe.
Oh,
and it's just a beautiful podcast. The young woman that does it at Goddard, I think she's just doing amazing work. Very well produced. It covers all topics of NASA science, but I believe there's more than one on Perseverance on the rover. So I think that'd be a wonderful thing.
Fantastic. And the name of that again was?
Curious Universe. Now I'll try to post a link in the
Universe. Awesome.
And I'm sure you could plug it into your podcatcher of choice.
Oh yeah. am sure you could, and we will definitely make some notes of that and the other wonderful links that you folks have given us. Well, I want to thank Dave Gruhl, Michelle Bauer, and Dina Lambert for being here from NASA. Thank you all
Yes, thank
so
you.
much.
Thank
Oh my
you.
goodness. We
Thank
have
you
so
for
many
having us.
people saying more NASA, more NASA.
Hey!
Ira in space.
Right. Do we get to go out with sound, Janine? Did I hear that
We
correctly?
do.
or-
Let's cue up
Yeah.
the sound, Julia. There
Yes.
is one of these sounds of the rover moving around. Yeah.
For driving.
Yeah, the
Rover driving?
driving. Let's listen to this.
So brilliant. Just this whole
Yeah.
thing.
Yes.
Absolutely love it. You know, we had, watching YouTube as we're going through, we've had so many people from their schools who are on here right now watching. We have people who are going to be doing plays on space that are watching, trying to get some ideas.
Fun.
We've had so
And
many other
listen to that in the background. They're
Wow.
clinking along. Oh, he's dragging his fender.
Roads with potholes. Road with potholes.
That's an amazing thing to hear. Like, I don't know.
I know. What's interesting to me is how that sound carries through that minimal atmosphere.
Oh, Janine, one last thing. For those
Yes,
for
ma'am.
students that are interested in working for NASA, we are always a workforce of all different types of fields. Please keep an eye out on our website, nasa.gov, usajobs.gov for updates for internships, because we are always looking for our next generation of explorers.
Outstanding. And one of you is going to be the first blind astronaut. I can count on it
Oh, yeah,
right
5,
now.
yeah.
Somebody
Oh,
out
yeah.
there in the audience will do that. Wonderful. Well, thank you all so much. If you'd like to learn more about IRA and visual interpreting, you can visit our website at www.ira.io. And please check if you are interested in working for us at ira.io/careers, because that's where our job postings are if you are interested. And thank you all so much. Once again, thank you, Stephanie and Ryan and Julia and our crew from NASA for making this a very special episode of Afternoon at the Museum.
Thank you, Janine.